Okay. Today class we discuss about elasticity lecture 3. Last class already we have discussed about the lecture 2. What we have discussed in the lecture 2 was strain, and different types of strains are also there, and different types of stresses are also there. Stress means what? How many stresses are there? Normal stress, tangential stress was there, and strain means three types of strains are there: longitudinal strain, volumetric strain, and shear strain also there. Already we have seen what is meant by shear strain. I already said you last example. If we are going to take this and apply a force here, fix it. So it is going to move like this also I said you. So this is an example of shear strain, right? And one more example I will tell you. If you fix a rope or wire rope here, and if you tie a stone for this, so rotate it like this, what happens now? Torsion will be developed now. And if you release it, what happens? Again it is going to rotate back like this one. See? Right? So this is called as what? A torsional strain, nothing but shear strain. And in this, what is going to produce? Torsion is going to produce. This is a live example of shear strain. And next we will go for the Young's modulus. It is represented by y. Y is nothing but normal stress by longitudinal strain. So normal stress is nothing but force by area by delta L by L. So y is equal to FL by A delta L. This is what you are Young's modulus. Also we know from this Young's modulus is equal to stress by strain in short. Stress is equal to y into strain. Just remember this. Next topic, we discuss about the thermal strain. What is meant by the thermal strain? See, for example, if there is a rod of length L at temperature T, I am beating it. Now temperature changing from T to delta T. What happens now? It is going to expand, right? Now this will be the delta L, right? Now what is your strain comes out to be? Delta L by here. Already what your delta L comes out to be in terms of thermal expansions. L alpha delta T, where this original length, alpha is the thermal expansion coefficient, delta T will be the change in temperature. Okay? So that comes out to be, if I put it here, cancel one go. This will be the what strain? So thermal strain, alpha delta. If I want to find stress, the stress equal to y into strain, right? Then y into strain and alpha delta T. If delta T is correct, this is going to become thermal stress. So thermal stress is equal to y alpha delta T. Clear? Yeah. That's it. Just make a note of it. So let's go forward. Thermal strain is equal to change in length. Already we know these things. What is the delta L should be taken as? Delta L is nothing but the restricted length. If it what is the strain comes out? In this, what is the strain? No strain. Simple. No strain. Because it's nothing but a free expansion, right? Free expansion like a strain. No strain. No. There is no stress developed here. Then there is no strain. Right? So then what I mean you will understand now so shortly. For example, if I fix this between the two supports and this is L at temperature T. Now I am increasing this temperature from T to T plus delta T. If it expand all then what happens now? If I leave this, it can expand this length, right? But I am not allowing to do This is called as what? Restriction. I am restricting it from expansion. Expand agakoodathu solittu. Right? That means what is going to happen now? So I am going to restrict this length, right? What is this restricted length comes out to be? Delta L. So here this delta L comes out to be restricted length. Restricted length by original length. So always remember now here, this is the restricted length by original length. Right? Make a note of it. Let's go for a question now. Let's see a question based upon this. Yes, sir. There is a rod given like this. The rod has a length of 1000 millimeter, and between the two supports, the length is 1001 millimeter. Then alpha is given as much. Length modulus of this rod is given as 10 to the power of 11 meter square. If delta T is 20 degrees centigrade, then find the stress produced. So, what is your stress produced to be? That's what they are asking. Let's see, sir. What is your approach comes out to be? Simply what you will do is stress is equal to what you can write. Stress is equal to Young's modulus into y alpha delta T, right? So what you will say simply 10 to the power of 11 into 10 to the power of minus 4 into delta T will be 20. Then how much you are going to get? 10 to the power of 11 minus 4 is going to be 7. So 2 into 10 to the power of 8 Newton per meter square. This is what you are going to get stress. So this is completely wrong approach. Right? Let's go for what is the correct approach. इधर जाना समझना टर्नल स्ट्रेन रिपो में what type of length you want to take is residual length you want to take. So what is your delta L comes out to be, sir? L alpha delta T, yes or no? And this delta L is what? L alpha delta T. This L alpha delta T. What is your L comes out to be actually? What is your original length, sir? 1000 millimeters. What is your alpha comes out to be? 10 to the power of minus 4 into 20. This comes out to be 2 into 10 power 8 is what your delta L, right? But what is the restricted part here? How much is the restricted part? Restricted part is nothing but how much you restricted actually. This one is 2 millimeters, right? Simply what you can say is 2 into 10 power 8 something you got, no? L alpha delta T. That is correct or not? No. 4, yeah. It's nothing but 2 millimeters. So delta is coming out to be 2 millimeters, right? But it's not 2 millimeters here. It is 1001. So how much is the restricted length? So that means you are allowing to expand 1 millimeter, but you are stopping 1 millimeter from expansion. So it can expand 2 millimeter, but you are allowed to expand only 1 millimeter, right? That means what is your residual length? Only 1 millimeter, because 1 millimeter only you are allowing to expand, right? And another 1 millimeter you are just restricting to expand, right? That means this will be your residual length 1 millimeter. And now finally y alpha delta T. If delta T coming out to be 20. So that is plus, yes sir. So how much is your delta T and everything if you put, no. First of all find this strain rate, yeah, sorry. Find this strain. Restricted length is 1 millimeter by original length 1000 millimeter. 10 to the power of minus. Now simple. Stress is equal to y into strength. Y is 10 power 11 into 10 to the power of minus 3. That is 10 to the power of 8 Newton per meter square. So this will be your calculation. Whereas in the last case we got 2 into 10 power 8. Here we got 1 into 10 power. So this will be your answer. Always remember, once again I repeat, strain is nothing but what length, sir? It's not the expanded length, it's the restricted length. How much you are restricting? It's 1000, but it can able to expand up to 2 millimeters. But you are allowing only to increase up to 1 millimeter. So you are restricting how much? 1 millimeter. So 1 by 1000. Right? Note it.